Hello again, grade 12s. We're going to continue on page 8 all the way to page 10 with the rest of 4.5. This is part 2. We are going to again be using the elementary differentiation rule that's highlighted in yellow at the top. If you don't have it on your page, write it again, put it in a box, put it on your notebook, etc. So we are looking to find the derivative. Again, that means to find the equation of the line that is tangent to the graph. So number 1, we're looking at y is equal to root 7x. Again, we want the question or the function to be written in this form. We've got a coefficient, we've got an x to a certain power. So here we see this is not in the exact form. So we need to manipulate this a little bit. Y is equal to, we know that radicals say that this is true. Okay, we can separate this as root 7 times root x. Then we know that root 7, that's our coefficient, and we have x to the power of 1/2. That's exponents and radicals. Okay, so once we have that, then it's as simple as applying this rule. So now differentiation, or y prime, equals root 7, that's the a, looking up here, times 1/2, that's our n, our exponent, times x to the power of n minus 1. So we have 1/2 minus 2/2. We write the fractions with common denominators, and our final answer then would be root 7 over 2 times x to the power of negative 1/2. Okay, number 2, you can see it's written in the exact form that we need. So to find y prime, a times n times x to the power of n minus 1, and it works out to 120 x to the power of 11. Number 3, again, this is not written quite the way we want it. So let's do a little work here. We've got the 4th root of 3 being multiplied by the 4th root of x cubed. 4th root of 3, that's our coefficient, and then we have x to the power of 3/4. Okay, so there's our f of x, and now we can differentiate that. So f prime of x is going to equal a times n, the exponent, multiplied by x to the power of n minus 1. I'll write the 1 as 4/4. And we can simplify that to be 3, 4th root of 3, all over 4. All I did is multiply those two coefficients there. X to the power of 3 minus 4, negative 1/4. Okay, let's move on to 4. Okay, here we also need to write this in the form that we need. So we've got 6 will be our coefficient, and then we see this variable is in the denominator. We know that negative exponents make that reciprocate. So I can write this as root x to the power of negative 1. Same thing, okay? Almost there. 6 to the power of negative 1/2. This is the square root. So we see that exponent denominator will be 2. Now it's in the right form. And there you can find the answer. I'm going to save time on the video by stopping it and doing this work. So here's our answer. And you can pause it and work through that if you need to. Number 5, we see that here, when we have an exponent onto the brackets, this exponent is onto all parts, so the coefficient as well as the variable. So we can rewrite this as 2 to the power of negative 3 multiplied by, now what do we do when an exponent is on an exponent? We multiply. So this is x to the power of negative 12. Okay, and then that equals 2 to the power of negative 3. Well, the negative makes it reciprocate. 2 to the power of 3, that is 8. 2 times 2 times 2 times x to the negative 12th. And here now we see we've got our a, we've got an x, and the variable n. And now we can differentiate that. Okay, and here's the answer of y prime. Okay, you can see I'm having a lot of fun with these different pens on the Smart Notebook. Number 7, we are looking here, and just one thing you need to add to your notes. This 5x should be squared. So when we look at this question, we see again that there's 3 terms. Each term is not in the standard ax to the power of n form. So we need to do a little manipulating here first. 3x. Now, when the variable is in the denominator, we know here if there's no exponent, it's a 1. In order to reciprocate, we know that we use negative exponents. So we write this as 3x to the power of negative 1, subtract 5x to the power of negative 3, plus 7. Now, I don't want to bring the 5 up to the top. I don't want it to be 5 to the power of negative 1. So I'm going to leave the 5 down there, 7 over 5. I'm just going to reciprocate the x. Okay, that x becomes a negative exponent. Okay, now each of these terms is in the right form, and now we can differentiate f of x. F prime of x will be equal to 3 times negative 1, negative 3x, to the power of negative 1, subtract 1, negative 2, negative 5 times negative 3, 15, times x to the power of negative 3, subtract 1, and then 7/5 times negative 2. You can write that out and do the multiplying later if you want. It will be 7 times negative 2 over 5 times 1, x to the power of negative 2, subtract 1, negative 3. Done. Here we're again asked to find the derivative, or we're asked to differentiate the function. Here let's multiply this out first. We've got 5x minus 3 times 5x minus 3. If you use FOIL, that works out to 25x squared minus 30x plus 9. There again we can see we've got 3 terms. We can differentiate that easily. We've got 25 times 2, 50x to the power of 2 minus 1. And the second term, we've got negative 30 times 1. Here, this power, it's not written, it's a 1. So minus 30x, x to the power of 1 minus 1, x to the power of 0, which we know is just 1. And then differentiate the 9. We know that the derivative of a constant will be 0. So we've got 50x minus 30 is the derivative. Okay, looking at number 9, not quite written how we want it to be, so let's rewrite each of these terms of fx. We see that the first term, we know that this is true. Root x divided by 3 is the same thing as writing it this way. So in the second step, we'll finish that. Here we've got coefficient 2, which is good. We've got x in the denominator, and I'm going to write a second step here. That's the power of a half plus 6. Okay, next here, we've got root 3 in the denominator. That's fine. We'll leave it there. X is now to the power of a half. Subtract 2. We don't want the x down in the denominator, so that's x to the power of a negative a half. We know the negative reciprocates in the exponent, and just the 6. Okay, so now we can differentiate that. I don't know how to turn that thing off. Oh, there we go. Okay, so f prime, get my pen back, is equal to, okay, we've got 1 over root 3 multiplied by a half. I'm going to write that out, and we can multiply it in the second step. Times x to the power of 1/2 minus 1. So we can write that 1/2 minus, I'll write 1 as 2 over 2. So it has a common denominator. and then -2 times a -1/2. You could probably do that one in your head, but I'll write it out. Times x to the power of -1/2, subtract 1, -1/2, subtract 2/2, and lastly, a derivative of a constant equals 0. Okay, multiplying these fractions straight across, we've got 1/2√3, x to the power of 1/2 minus 2. Okay, 2 negatives here, we'll make that a positive. It'll be 2/2, positive 2/2, which is just positive 1. I don't need to write a 1. X to the -1, subtract -3/2. Good. And here, I know we don't usually leave root signs in denominators. We're going to be fine with leaving it just like that. Flip the page, and let's move on to number 10. Number 10 is given to you just to get you used to the idea of using different variables than our x and y that we usually use. So here we've got a, that's often replaced with y. Sometimes that was replaced with f of whatever the other variable is, in this case r. And here's a variable r. Usually we've written that as x. It doesn't really matter. Now, the point being here, we're asked to find the derivative. The derivative of the function, in this case it's called a, divided by the derivative of the variable, what we usually say x. So here we say d of a over d of r, or we're finding the derivative. Now, 2 pi is the constant, and r is the variable, 2 is the exponent. So we've got our the constant, the a, multiplied by the exponent times r to the power of the exponent, 2 minus 1. So we're finding that our derivative would be, or dA with respect to dr is equal to 4 times pi times r to the power of 1. Don't need to write it. Okay, number 11. Okay, here's a question to make you think, and I'm using the magic pen now, so you're going to see it disappear. Okay, we're supposed to find two coordinates, or the coordinates of 2 points on this f of x function. Whoa, fancy. Given by this function, where the derivative at this spot x is equal to 6. Okay, so let's see what the derivative is of this function. 3x to the power of 2 plus, you must be getting good at this by now, 6x to the power of 1. Oh, it's disappearing too fast. Let's go to regular pen. We'll just do it in red. Oh, that's funny. F derivative of x equals 3x plus 6x to the power of 1 minus 3x, 1 minus 1, 0. Good. Okay, now it says here that this derivative equals 6. So let's solve for x here and find two x values where the derivative equals 6. So we've got 3x plus 6x minus 3. If I want to bring the 6 over to the left, I subtract it from both sides. I've got 3x plus 6. Whoa. This was supposed to be a squared. Okay, sorry, I hope some of you caught that on the way. Minus 9 equals 0. If we factor that now, we've got, first let's take out a common factor. And if I factor that, we've got x plus 3, x minus 1. If you want to stop the video and figure that out, you sure can. Okay, so we see here, if this equals 0, we must have an x of negative 3, or we've got an x of positive 1. So those are the two spots where this derivative is going to equal 6, where the slope of the tangent line is 6, meaning it's this line, these two spots, is going to have a slope or a rise of 6 and a run of 1, right? 6 is over 1. So you can imagine these two lines at x equals negative 3 or x equals 1 of that function. Okay, so I put the x in, found the y, there's the 2 points, and here's your assignment.